try to explain some of what's going on. So this is the chart I had on the board. I mean, I think I had it written like horizontally instead of vertically, but it's the same idea. So sample mean, the mean is going to be x bar, which is going to be equal to mu, as long as it's unbiased. The sample standard deviation will be the population standard deviation divided by the square root of n, and these are the conditions that have to be met. For proportions, the sample mean is p hat, and that's equal to p as long as we're unbiased. And then the standard deviation is this, and these are the conditions that have to be met. So quite a bit of the test was knowing this stuff. So like if I look at number 1, which of the following conditions is it not appropriate to assume the sample mean is approximately normal? Well, in part A, we're taking it from a normally distributed population, so we're good. In part B, we're taking it from a normally distributed population, so we're good. In part C, it is not a normally distributed population, and it is not a large enough sample, so that's no good. D is okay because that's bigger than 30. E is okay because that's bigger than 30. Number 2, which creates a biased estimator. So biased means we're doing something, like we're not doing it randomly. We're doing something flawed somehow so that our process, like if we're trying to estimate, the percentage of people that have cheated on a test, but I'm doing it in a way that is like public, let's say. I'm not going to get the true answer, so my estimate of what's going on is not going to be equal to the true population answer. So these two are different. A few people put C. So if this word was the word mean, C would have been a good answer. But when it says shape, the original graph can be skewed right or left, and the sampling distribution would still be approximately normal as long as you took a big enough sample. Number 3, so this is kind of a major concept also. So they give me 2 numbers here. The population proportion here is p equals 0.05. So that's your big, like everybody, all the gigantic, huge group population, p is 0.5. Well, then I take a tiny little sample of 100 people and find out that that's 7%. So the mean of the sampling distribution, so what you got here is like that, you get a big population up here where the mean is 0.05. We take one little tiny sample and we get 0.07, and they want to know the mean of this sampling distribution down here. Well, this 0.07 might be like one of the little samples, but remember the sampling distribution is all of the little samples that come together, and the mean of those will be the same as the mean of the population. So kind of the idea is which carries more weight, the population data or the sample from this one little tiny, or the data from this one little tiny sample. But it's always going to be the population data that means more if we have it. So the mean of all the sample proportions is 0.05 is what you want there. So this one says like for all random samples we'll get 0.05. Well, that's not true that every single time I take a sample I'm going to get the same thing. This is 0.07, so it's out. This is 0.07, so it's out. And E is some weird way they're trying to combine those numbers. 4 is the same idea. So 46% of all city residents. So this is your big population data. Then I take one sample of 150 and I get 51%. So if I were to take sampling distribution, it's taking a bunch of samples and averaging them all together. If I take a bunch of samples and average them all together, is it more likely to equal the true answer or this one little tiny sample? And the answer is the true sample. It's approximately normal because we took a big enough sample, so we can get into the NP and Q there, but that's not even really the main idea here. And the mean is 0.46. Well, I guess we do have to know if it's normal or not. So you'd have to do your NP and your NQ and see if they're greater than or equal to 10. You took 150 people. Your sample was 0.51. And so those are both going to be much bigger than 10. So it is approximately normal. The more important thing to me is knowing that the mean is 0.46. Number 5. So this is a randomly chosen task. So this is just from the population. So this is not even a sample problem, but It's in the sampling chapter to kind of mess with you. So less than 34 minutes or more than 60. So what I'm going to do is find the probability that it is between 34 and 60. I'll do 1 minus that. So then the mean is 47, the standard deviation is 6. And there's no like sample of 20, so you don't have to divide by the square root of n because there is no n. And then if I just type this in, I get 0.0303. Yeah, which is B. All right, number 6. So they're asking you, how do we know it's normal? So that's getting back to this thing here. So this is how we know things are normal. So the first job is, are we dealing with means or proportions? And we're dealing with proportions. And then how do I know that it's approximately normal? Well, this is a condition, but it's for means. This is not a condition at all. This is not a condition at all. This is not a condition at all. And this is one of your conditions. Number 7 was rough. Number 7 was a very hard problem. I think 2 people got it right. No, more than 2. There were 200%, but this is a tough one. So they don't give you the standard deviation. So you got to kind of, what I did was guess and check. So they tell me the probability that the water level in the lake is at least 100. So 100 or more, 100,999, is 0.064. And they give me the mean, and they don't give me the standard deviation. So what I did was go, okay, normal CDF, 100,999, 84.07, and I just guess. I took a wild guess, like what do I think my standard deviation is? And I started with 2, I think. And I got a super tiny number. So that tells me that my guess is wrong. And then I was like, well, let me try a bigger number. If I get closer, I'm going in the right direction. And if I get further away, I'm going in the wrong direction. So I tried 5. And that got me a bigger number. I'm trying to get to 0.064, remember. So that got me bigger, so I'm on the right track. And then I think I tried 10. Remember, I'm trying to get to 0.064, so that's close. But then I'm like, okay, let me go a little farther. Let me try 11. And then I noticed that 10 was too small, 11 was too big, but it's pretty much right in the middle of those. So then I tried 10.5, and I got 0.064. So that is the way I'm trying to find the standard deviation. And that was my approach to find standard deviation. And then, once you know standard deviation, they're saying, what's the probability it's bigger than 90? And once you know standard deviation, you can just do regular old normal CDF using that 10.5 that we just found as your standard deviation. And if you type that in, you get the answer. It's like 0.286 or something, which is A. And again, that one's rough. I'm not saying this test is easy, especially that one. Number 8, which of the following is the shape of the sampling distribution of the sample mean? Approximately normal. So these are the conditions for sample mean. That's what we're looking for. Number 1 is from a population that's approximately normal. So normal population. So we got that covered. So that's good. Number 2, so the sample size is too small, number 1, but that's okay, because the population is normal. Number 2 is a small sample size, and the population is not normal, so we got 2 chances to get it right, and we didn't get either one of them, so it's no good. Number 3 is not approximately normal, but we have a large enough sample size, so we're okay. Number 9 here. So 80% effective, that tells me P equals 0.8, random sample of 100, which is the best description of the shape of the sampling distribution. So this is proportions. So I'm looking for these conditions. It tells me it was random, so that one's good. I need to make sure I'm taking less than 10% of the population. Well, there's probably more than, 100 is probably less than 10% of all the people with a rash that will use the cream. And then I need to know that NP and NQ are greater than or equal to 10. So NP and NQ, well, N is 100, P is 0.8, that's 80, that's good. N is 100, Q is 20, or 0.2, so that's 20, and that's good. So as long as those things are all good, then we're approximately normal, and that one's C. Number 10, order the graphs from the least value of n to the greatest value of n. So the smaller n is, the more spread out the graph is. And when you get a bigger n, you get a more tightly compacted n. So remember, the standard deviation divides by the square root of n. So that as that number goes up, the overall value of this whole thing goes down. And when you get a smaller value of the standard deviation, it's going to be more tightly compact. So the lowest, so least to biggest, so the least value of n is going to be the one that's most spread out. So A is first, and then the next most spread out, and then finally the skinniest. So it should be ACB, which is A. Number 11. So describe the sampling distribution of the sample mean. So we're approximately normal because we've got a large enough sample size. You know, there's more than 10%. This is less than 10% of all the houses in the world, or Western city, whatever it is. And then it's random, so we know it's approximately normal. And the main thing they're asking here is, do you know that because it's a big enough sample size? So once we know it's approximately normal, we can get rid of those two. The mean of the sample is going to be the same as the mean of the population. The mean of the sampling distribution will be the same as the mean of the population. So the mean is that, but that doesn't help us because it's the same in every single one. And then the standard deviation is going to be the standard deviation of the population divided by the square root of n. So it's that 37,881 divided by the square root of 100, which is just dividing by 10, which is going to be this 37888 number. And that's it. And then number 12 here, and again, this is getting that idea of what number carries more weight, the population data or like one random sample. So they're telling me here that in a large corporation, like the entire population data is a mean of 20.6. Then they take one random sample and they find 20.3. But that's just one sample. And if I did this over and over and over again, the number that really carries the most weight is that 20.6. So that's going to be yes. He is right. The mean of the sampling distribution would be 20.6. And then this part was a little different depending on which version you took, but the general idea is the same on all of these. So this one is not from a sample, so this is just normal CDF, 25,9999. Then you tell the calculator the mean, the standard deviation, and you get that 0.0912 number. Part B, well now I'm taking a sample of 30 students. So you have to divide your standard deviation by the square root of 30. And this came out to like something e to the negative 16th, which is basically 0. And then part C, what is the shape of the sampling distribution? It's going to be approximately normal. And this is sample means. So basically you're listing these things. And there's 4 of them there. And I actually had another one up there that was like known standard deviation. Which if you put that, I was fine with. So you could have put any 3 of these things and been okay. Number 3, if a statistic, so if our sample gives different information than the population, that's what biased means. If we're doing the process incorrectly, doing it more often is not going to help. You know, that's like if someone doesn't speak English, I'm just going to talk louder. That's not going to help anything. If I'm asking people in public to declare if they've cheated or not, and I just take a bigger sample, I'm still biasing the process because I'm doing it in public, so doing it more often is not going to help. So that's no. Part A down here, this will be normal CDF, 0.75, 0.85. The mean is 0.8, and you took a sample, so your standard deviation is going to be 0.8 times 0.2 divided by 200. That comes out to your 0.923. And then what is the shape? And again, this goes back to this chart. So it's approximately normal, and then these are your 3 reasons. You just had to kind of list these out. So hopefully that helps. If it didn't and you want some more help, please come and let me know.